working quite okay. I'm just trying to also learn more about Knative and see how can I contribute. And by just creating simple applications, it's pretty clear to me that, or I might be missing some stuff or some stuff that we can create in order to make like, you know, the user experience a little bit better. Not on the Knative stuff, but in some components that can help people to build like applications basically. So let me try to go over the application. My name is Mauricio Salatino. I do work for a company that's called Comunda. They have been doing workflows for a long time, and I've been working with workflow related companies for the last 10 years or so. So I've seen like a fair share of implementations of applications using workflow technologies and how, you know, they create these workflow engines. This company has a project that's called Zeebe. That's the one that I'm going to be showing today. And that project, basically, it's a cloud native re-implementation of what we traditionally know as a workflow engine. That's quite cool. It's adapted to, you know, the modern infrastructure. And I'm also a Learn K8s instructor. We do Kubernetes trainings for that. I'm pretty sure that we are all familiar with Kubernetes by now. So a quick disclaimer here, I will be running a live application running in a remote Kubernetes cluster. It's using WebSockets and Knative cloud events and a bunch of other stuff. So what can possibly go wrong? I would say everything. And if something can go wrong, it will go wrong. So don't laugh too hard if the demo fails. But feel free to stop me at any point while I'm showing things, because the main idea here is that if we can make it interactive, or if you have feedback at any particular point in time, let me know. So let's take a look at the application. So I built an application that is composed by 4 microservices, and it's simulating a tickets portal. All the source code and all the references for building and running this application in your own clusters can be found here in this repository, Orchestrating Cloud Events, under my account. That's in GitHub. It's kind of like a work in progress. I will keep adding more information the more I build the application, but now it's in a situation where you can just build it and run it in your own cluster if you want to. So let's take a look at the application. Let me go out here. Let me go to the application. And the application, again, is simulating that idea of you need to sell tickets for, let's say, a concert that it's in high demand. And you probably have less tickets than people wanting to buy the tickets. So you might need some kind of queuing system in order to be able to serve, you know, in a first come, first serve approach, right? So in order to do that, you will need to have some kind of a queue, and you will start queuing customers while they arrive. And in the moment where the tickets go on sale, you are going to start processing that queue and just letting a bunch of customers at a given time to proceed and reserve the tickets, right? If they manage to reserve the tickets in their session, they will just acquire the tickets. If not, they will just leave the tickets for the next person in the queue, right? So this is basically the application. What I can do here is I can generate some, you know, sessions just to simulate that there is people in the queue here. So now I have a queue with, let's say, 10 people. I can join the queue in there, and I'm now 10 because there one just left the queue, right? And I can generate more at the end as well, just to simulate like a normal queue, right? Like I'm there in the middle, right? And one interesting thing to notice here is that I will be refreshing the state of the queue for every customer using WebSockets. So I'm just pushing events to each of the, you know, customer browsers in order to just update their position in the queue, right? That's just a thing just to take into consideration from like the architecture of the application. So what I can do here is I can just simulate people just going out of the queue. So I just jump towards the first place, just remove that. And now I'm in the beginning of the queue. So next it's going to be my turn. I can wait for that and make that happen. And again, I will be just notified because I'm getting a WebSocket notification message saying, yeah, now it's your turn. Now you can reserve your tickets, right? And as you can see, there are a bunch of weird IDs there that represent my session and basically will validate that I am now, you know, allowed to move forward into the process of buying my tickets. And here you can just select the amount of tickets and the type of tickets, right? Let's say I just want to reserve 2 tickets. And as soon as I click reserve, the main idea here is that I'm going to go to the pool of tickets, available tickets, and I will lock, in this case, 2 for my reservation. And those tickets will be locked until I pay for those tickets. If I manage to pay correctly, then the tickets will be mine. If I do not manage to pay correctly, and for some reason there is an error, or I just do not pay, those tickets are going to be automatically put back there into the pool, right? And as you can imagine, if you have a payment service or a payment system, it might be kind of like a third-party payment system. So as soon as I click pay here, I will just send my details to a third-party application, and I'm using an iframe and again a callback in order to verify that the transaction was approved. So when I click here, I'm just going to a third-party application. This is not the application of the tickets portal. It's a third-party thing. And then I'm just waiting for a callback to come back and say that my transaction was approved or rejected. It was approved, and I also get a WebSocket notification saying, yes, you can continue and you can get your tickets. So that's pretty much what the application is. That's kind of like the normal flow of the application. And based on this, you can go and say, okay, if you want to architect an application like this, you can use like an event-driven approach, right? And if you use an event-driven approach, basically what will happen is that you're going to be emitting events. Some services will be emitting events, and some other services will be consuming events, and in order to make all this flow happen, right? So these are kind of like the events that you would expect to have in these kind of like situations. You join the queue, you exit the queue, you reserve the tickets, you send the payment gets authorized, and then the tickets gets emitted, right? If you go more to the architecture, this is kind of like how I started working with this application. So I created 4 different services. The front end, which is interacting with WebSockets to the client to the browser, sending messages, and also sending the HTML for the website. A ticket service that is in charge of interacting with the payment service and also to emit the tickets, and the queue service, which is in charge of this queuing mechanism that you saw at the beginning. When I started building these services, I started saying, okay, let's use cloud events to share information between these services. And I started using like the HTTP bindings, so sending HTTP post requests between the services. And at that point, my services needed to know exactly where I was sending those requests, right? So from the front end, if I want to interact with the queue service, I just need to send a post request to the queue service that pushed me to know in the front end application to know where the queue service was, right? And you can quickly do that. You can easily do that. But if you're building a more real life application, you might need to have some more advanced stuff. And we are in the Knative meetup, so I don't need to explain what Knative serving or Knative eventing is. But I started looking quite heavily into Knative eventing in order to implement a more robust solution of communicating this service together to be able to scale it. So I started using Knative eventing, and you ended up with something like this, where you do not communicate the services between each other. You just send messages to the broker using a channel. I started with a memory channel, and then I switched to Kafka. And you have a broker where you just publish your messages or your cloud events, and then you create triggers for subscriptions for those events. So different services will subscribe to different event types, and by creating the right subscriptions and by publishing the right cloud events to the broker, you can like implement this flow. At some point, I needed to create some kind of a checklist to understand how the flow was composed, right? It was something like this. I said, okay, the front end needs to generates a cloud event that it's being pushed to the broker, and then there needs to be a trigger in the queue service to consume that event to do something. And the same here with the queue service. When the queue service generates the customer exit event, there needs to be a trigger in the front end to be able to consume that and allow the customer to move forward, right? So for this very simple scenario, I needed this checklist, and it's kind of like, I can definitely understand it now, and it's easy to build, but you can imagine that if you have tons of triggers and tons of these subscriptions and tons of messages being generated, it might tend to become a little bit more complicated. So definitely, kind of like my first experience was, okay, yes, I know how to build my application. I know how to create these things. The idea of creating triggers on top of the broker, like subscription-based, that you wire more like in runtime, not when you're designing your applications. So your services doesn't know about each other. It's pretty cool. It's very declarative, and I really love that thing from Knative eventing. But it becomes kind of like a thing, like how do you visualize how things are being connected together at a given time? What's the sequence of events that needs to happen in order to complete the flow? What happens when you want to change this sequence? And how do you understand what was the sequence that was executed yesterday and what's the sequence that it's required today, for example? It's hard to see where things are at the given time. You need to implement some kind of like your own dashboard to understand what's going on. And when things go wrong, it's also difficult to understand what exactly is going wrong, right? Like, did you miss a trigger? Did you misconfigure a trigger, or what's going on, right? So it's good to know that Knative also have Knative Flow, which basically implements a bunch of things, a couple of constructs, sequence and parallel, that allows you to start defining and in a declarative way these kind of things. And it's really nice from these concepts. Again, I will not spend time explaining these concepts because it's the Knative meetup. that again, you just define them declaratively, and they also start doing interesting things like automatically provisioning channels in this case, right? Like you have a channel template that basically means that every time that you create one of these sequence, a channel will be created for hosting, kind of like serving that sequence, the same with the parallel, right? And again, this definitely it's going in the direction where you can define, you know, this important sequence of events, or how to process a cloud event against like different services, how to send, how to route events across multiple services, which is a really interesting idea. And that's why I wanted to talk a little bit about Zeebe, because Zeebe, it's a workflow engine, and it's basically designed for doing these kind of things. So there is an overlap there with Knative Flow, but this is, I would say that this is a little bit more high level, right? It's not a replacement for that. It's overlapping a bit conceptually, but definitely consider this on top of it. Like it's like a different dimension. It's just to provide visibility, and I will be showing that. And Zeebe, it's something that you can install in your own clusters like Knative. You can use Helm charts in order to install it and just provision all the components that you need in order to run this in your cluster. Or you can use you know, a hosted managed approach where you just instantiate some of the stuff in our clusters and then you just connect to them, right? And I will be using that for the demo later on. So the architecture, when you're using Zeebe in this case, it's pretty simple because again, the only thing that we can do here is we can just tap into the events that are being already emitted by our applications. So we have Zeebe here. The only thing that we'll be doing is looking at the events that the application is emitting. And what we can do is we can do the first thing, which is understand what's going on, right? So we can create a model like this one, the one that I'm showing here. I can show it into this other application, which basically the only thing that I'm doing here is I'm mapping a high-level view of what's going on by defining this model, which is saying every time that I get a new, you know, customer join event, I will just create one instance of this model, and then I will keep waiting until this next event happens, and then until this next event happens, and then until this next event happens, and the same here, right? By the end, I will be able to see how many, you know, if I just look into a dashboard that it's showing me all the instances of this model, I will be able to see how many people is trying to buy tickets and how many are stuck in the payment section, for example. And that's pretty powerful because when you have like this, you know, event-driven applications, you might end up having like loads of different events at different levels. You know, one more technical events, more high-level events. And with this, you can choose exactly which events are you interested and then map them into a model like this. And again, here, we are not influencing the application behavior in any way. We are just, you know, tapping into the events that are already happening and then just, you know, mapping that and visualizing that. So now I'm here again at the beginning of the application, and I can join the queue. And I can go here to a tool that comes with Zeebe, that it's hosted there, and I can refresh this. And I need to kill all these instances. These are the instances that I've started before when I did the first demo, and I had like 20 instances running in there. And I completed one of the flows, right? And now I created a new one, which is the one that is here. I'm already out of the queue. I should reserve my tickets. Let me see if I can order them in the right way. So this should be the instance that I'm looking at, right? So what I can do here is I can just reserve the tickets. Let's say that I want to reserve 4 tickets. And I should be able to see here that this, you know, flow, it's moving forward. As soon as it receives the events, it will move forward, right? Now it's waiting for the payment. So pretty easy to visualize. If I go back to the dashboard, I can see all the instances that are running, like with a quick, you know, quick overview, exactly where my customers are by just mapping the application events that are already happening, right? That's one thing that you can do with Zeebe. Let's move to the next one. The next thing that you can do is you can take one step forward, right? Usually I tend to show this kind of like diagram, but because we are in a Knative meetup, I decided to go a little bit deeper on how the architecture of the integration works. And it's pretty simple as well, right? So what Zeebe has is here something that I'm calling Cloud Events Router, which is basically the one that it's tapping into the broker for my application, where the messages, where the cloud events are being sent. It's picking up the events and then forwarding those events and mapping things to an instance of the workflow engine. The dashboard that I showed before, it's called Operate. That's the yellow box there in the bottom. And the workflow engine has been already provisioned and it's running in Comunda Cloud. So it's not running in the same cluster where I'm running the services of my applications, but the workflow engine can be provisioned in the same cluster if you need to do that because you are in an on-prem solution or something like that. And because of this kind of architecture, nothing stops us to say, okay, now we want to, create the triggers for notifying the cloud event router about the events of my application. So the only thing that I needed to do in order to tap into that broker and get the events being sent to the workflow engine is just to create an extra bunch of triggers just to send the normal events to the right services, but all the events also to the events router that I have, right? And the funny thing is that because I have a model here that it's defining already the interests in different event types, I can automatically generate those triggers dynamically. There is no need for the user to create these extra triggers, right? If they are defining models that are interested in events, those triggers can be automatically generated and deployed into the cluster for automatic forwarding of those events. And that takes us to the second thing that you can do when you're using a workflow engine, which is providing a lot of other features around what you can do. Instead of just visualizing, you can start decorating and enhancing your flows, right? So one of the things that you can do, as shown here, is you can start adding timers, for example, for time-based notifications, and something that is quite common, keeping track of time and then sending notifications or executing actions after a certain amount of time happened, right? So let me go out of here, just go to the model. What I have here is the second version of the model. And what I'm doing in the payment section is basically adding two different timers. One timer that is non-interrupting, that basically means that I'm going to do something that is not going to influence the flow of the application. It's just going to, in this case, send a reminder, right? And then I have another timer that is going to influence the flow of the application in this case, and it's going to just notify the user that the reservation was timed out. So this is a little bit more aggressive, right? This is going to do something. And then I have these two extra boxes, which are basically creating cloud events. So I'm just going one step further, and now I'm generating cloud events from the flow, right? So if I zoom out, and if I deploy this new version, so basically what I'm doing now, if you're using a workflow engine, usually you have versioning like built in into these tools. So I can deploy a new version. I should be able to go back to the dashboard and see here that I have a new version deployed. Let me see if I have a new version. Now I have a new version, and I've configured my application just to basically use the latest version all the time. So now if I have a customer that is coming back here at the beginning, it's coming back at the beginning and joining the queue, it's going to start using the new version of the flow that I've described here. So at some point, if I refresh, I should be able to have a new instance coming, being created here with this model. And of course, it's going to take more time than usual because it's a live demo, right? That's how it works. Yeah, that's really interesting. Let's wait for a few more seconds. If it doesn't appear there, then I will try to start it again. It's not appearing. That's really interesting. It just picked up, I think that it picked up the last session, so let me do this. So let's join the queue again. That usually happens. Let's see if this picks up the right one. Now, there you go. So now we have the new instance here with the new version. And you will see that as soon as I go out of the queue, reserve my tickets, let's say 4 tickets. Now I need to pay. Now I'm here. Now remember that I've changed the model here just to schedule some timers. So as soon as the workflow arrives to this stage, every 10 seconds, it will start sending a notification. That's what this timer is saying. Every 10 seconds, you just do that. And that sending notification is basically creating a new cloud event that it's sent to the broker. So any application can be picking those events. And in this case, the front end is already configured to pick those events and show here a notification. Right? So I have a cloud event being emitted every 10 seconds. It's appearing here. And then, as I mentioned before, I have another cloud event that is going to be generated when the reservation timeout after 2 minutes. And we can see that if we wait for 2 minutes, we are going to be kicked out from our current session back to the queue, right? I will not wait for that, but believe me, that's exactly what's going to happen. After 2 minutes, this session is no longer valid. You are just going to leave, this spot for the next person to be able to buy the tickets. So as you can see, you can start decorating these things, and now you can start taking actions. That takes us to the next level, which is a little bit more complex, which is orchestration. And I know that orchestration is a very overloaded term, but we need to talk about it. So, and this is just kind of like the thing that I was showing before. Now the event router can generate events, and then the front end can register to those events as well, right? Like that's kind of like what the demo was showing. And finally, like again, orchestration, we in the workflow terminology, orchestration, it's a little bit more about taking control and making, flow control and decisions based on the data that we have. So orchestration is when you take control of the things, of the flow of the application. So not only consuming and mapping things that are happening, but also executing things in the flow, right? So you can do stuff like this, right? So you can have a more complex flow, which is, for example, in this case, using a subflow here, that it's basically saying every time that we start buying the tickets, we are in customer buying tickets stage or milestone or something like that, or like, in this space. And for more bigger and more complex flows, that makes a lot of sense because you might end up having lots of events being emitted or consumed, and then you want to separate them in different stages. And it also allows us to register these kind of like boundary events that basically allows us to say, no matter where we are in the flow, if we receive one of these events, customer abandoned the queue, we will just exit here, right? And we will have all the data of where the customer was when they decided to abandon, right? So also, as you can see here, it's like we are just not listening to events, but we are also generating events in the middle of the normal application flow, right? And this basically having these kind of tools that allows you to change the models dynamically and deploy new versions of the models allows you that flexibility of changing and adapting to changes in the business side, right? So I can show you that example as well, which allows us to see a little bit more about like tracking different ways of ending the flows. So if I deploy this one again, I will have a new version of the flow, a new version of the model, and when I join the queue again, I will be using this. But now I will be able to abandon the process, and I should be able to see that I have a bunch of customers going into that direction and a bunch of customers completing the normal flow of the application. So just quickly show that. Let me see if I have the new version. I have version 10 in there, and I can definitely start creating new instances for that here. So I will join that queue again. I'm just getting again here a notification. WebSockets become kind of like one big part of what I was trying to do, and I realized that I can definitely start reviewing and researching a little bit more about what's implemented in the community for WebSockets specifically, because if I want to really scale this application, that cloud events routing through WebSockets to the right browser based on a session ID or something like that becomes quite complicated and something that everybody will need just to code by hand unless I'm missing something. So it might be interesting to create some kind of like router for WebSockets that does that automatically. So we can go here and you can see that I'm in the new section. Again, this here is highlighting that there is one instance in this section. And if I go and generate more instances here, you should be able to see that now you have more instances being created there. Now you have 11 instances in this section. You see 10 are there. And I can go here to the backend to remove some sessions. And that's basically automatically generating that customer abandon queue event, which is basically keeping track of how many of these executions are going through that path. At some point, they will just go there, believe me. And it might be because they are completed already, right? So I can see here also with some filters, how many were completed, how many are active. And also something that I didn't show that I'm planning to add to the demonstration is incidents. So finding when things are going wrong, right? Maybe getting events out of order, or maybe getting something that I was not expecting that will be reported here. And we have some tools in order to be able to retry or to resend events if that's needed. So hopefully that makes some sense. And just to mention again, because I'm in here in the Knative Meetup, we have something that it's called the Zeebe operator, which is basically provisioning these workflow engine instances. And that's the one that should be in charge of every time that we deploy a new version of our workflow, to go through it, scan it, and understand how many triggers do we need to create. Right now, I'm doing a bunch of that stuff in the Cloud Events Router, but that's the responsibility of the operator, where we also have a CRD type for the workflow definition, the model that I'm showing here. So basically, there is a CRD type that takes this model and allows you to declaratively say, I have a new flow, just apply it with kubectl, and then automatically deploy that into the infrastructure, deploy that into the workflow engine, generate all the triggers that you need, and then just allow the users to create new instances of those things. And of course, that operator nowadays is creating instances in your own infrastructure, but it's part of the plan to also be able to create instances remotely on the software as a service approach as well. So that's kind of like one of the things that I will be working on in future iterations. Next steps for me, like based on where I am right now, it's definitely work a little bit more on those templated channels, like in sequence and parallel. So I just want to be able to replicate the same experience that those Knative, native types have. That idea of creating templated channels and kind of like improving the mechanisms on how I'm doing things on the workflow side. That needs some more refinement, than I will appreciate any feedback around that. Workflow engines also, they are being built by default to mix and allow interactions between humans and systems and events in this case. So what I want to add to the demo is something like an intermediate step. So for example, in here where the user is, like there is an admin user or someone that needs to execute some kind of like tasks that requires a specific form and a specific connection. So I can just model that and include user interactions in here. If I'm interested to do that, there are some use cases that make it more clear for like, for high level uses. And again, the thing that I mentioned about WebSockets using Stomp, I'm not using Stomp now, I should be using Stomp. And also I was looking a little bit into RSocket, which looks pretty promising. So kind of like trying to understand if the Knative community is interested in having some components around that, just to forward cloud events and just to being able to build these more kind of like reactive applications. So that's pretty much my presentation. I hope that I didn't spend too much time on it. And I hope that I give enough information for, for getting some feedback from this amazing community.
Thank you so much. Do we have any questions, comments for Mauricio? I think there was something, yeah. Evan? Wait, we can't hear you.
I noticed that one of the steps you had looked like it was a delay.
One of the steps that I had was a delay. Let me see. Let me go back.
Is that a function or some sort of built-in thing from Zeebe?
Can you point me out to which one? So for example, like these ones?
Like the payment reminder, yeah.
So this is not a delay, this is a timer. So this is like a recurring timer that it's going to trigger an event every, like a timer definition, right? Like, so you can say every 10 seconds, just repeat and generate that event. And as soon as that event gets triggered, you're going to execute whatever this is in this case. And you can add any number of steps.
I guess my question was, is that actually a function that's running where the container is sitting there for 10 seconds doing a sleep? Or is that like some sort of multi-tenant service where like there's one container for the whole cluster?
Yeah, that's a good question. So in general, let me go back here. So that's part of this piece, right? The workflow engine will solve that for you in a transparent way. You don't really need to care where is that running. Because again, the functionality that that's providing, it's just the timer service. It's like a cron job kind of thing that it's transparent for you on how it's running. And in the back, what is happening is that this workflow engine is not just a single entity. It's not just a single container. It's a bunch of containers that are executing these workflows. And they are keeping track of time and when to trigger those notifications.
I guess my question was, would that be a useful piece of functionality for Knative eventing to have?
I think that that's a quite common requirement for building applications. So having like ways to schedule timers. So I would say yes, these components are already implementing some of those. So how do you define that in Knative as well if you don't want to use these components? It's a very good question, yes. I could think that it might be a good stuff to have.
I hand so-and-so an event, and 10 seconds later, it comes out the other side.
Exactly. But again, so so you are here, you're scheduling a timer to just fire something, right? So this is not delaying that event for 10 seconds, is every 10 seconds just emit a new event, right?
Yeah, you're basically creating a temporary cron job.
Exactly. Yeah.
Like,
That's it. Yeah, that's it. And you are also, the other thing that it's important to notice here is that this cron job is going to automatically be cleaned up the moment that you move forward. Right?
How do you,
Because
how do you clean, sorry, yeah, I didn't want to interrupt, go ahead.
No. So basically, the main idea here, what this model is saying is that this timer is useful when you're waiting for this event to happen. But after this event happened, then you just don't need these two timers because you are just in a different stage now.
Yep.
Does that make sense?
Yeah, oh, it totally makes sense. I mean, the super hacky way that you could do this today would be to go ahead and spin up basically whatever the ping source is, right? To go ahead and emit an event. Tricky bit is when do you you would then have to go and manually clean it up.
Exactly.
Yeah.
And again,
but yeah, no, that
the workflow engines in general, they implement this because it's such a recurring, business requirement to have these kind of notifications and the cleanup mechanisms that they just built it in.
Yep.
Any other questions?